Okay, question 4a asks you to describe the transformation of each parent function and graph the function. So in the description, what I wanted you to do is use some of the terminology that we used for our transformations. And there are a couple different transformations that are occurring in this problem. First of all, I notice that my parent function is y equals x squared. So I know it's going to be a quadratic, it's going to be a U shape. Now, how we're going to change this U shape is by subtracting one inside grouping symbols, and every time it's inside grouping symbols, it was a horizontal transformation. So I know I have a horizontal transformation, and because it's addition and subtraction, it's going to be a horizontal slide or translation. Translations were our slides, left and right. And because it's inside grouping symbols, it's always a little counterintuitive. So if it says -1, it moves it to the right 1 unit. The other one is on the outside of the grouping symbol, so it has to be a vertical transformation. And this vertical transformation, since it's multiplied by a negative, is a reflection across the x-axis. Those are the descriptions that I'm looking for. What kind of transformations did we use in using the transformational language of translations, reflections, or dilations? And dilations we can talk about later when we hit them, but those are stretch shrinks. So, all right, so what I want you to be able to do is get a good, accurate picture of this. So I'm going to show you a different model, or at least hopefully show you another way that you can reflect on these. So I know the parent function of y equals x squared. If I look at a list of ordered pairs for that function, we don't need a ton, but if we had a -2, we saw that square root of -2 is a 4, -1 is a 1, square root of 0 is a 0, square root of 1 is a 1, and square root of 2 is a 4. So if I graph the parent function, it would look like this: 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. So that's what the parent function would look like. But we have to do our transformations. We have to shift it to the right, and we have to reflect it across the x-axis. So what I'm going to do is show you in some ordered pairs also the changes that are going to occur. So if I do the next transformation, which would be an order of operations, we have to go x minus 1. So the x minus 1 is a horizontal shift, and we want to make sure that every one of our x values gets shifted, and I'll show you in the graph, right 1, so it's got to go here. So the 0 becomes a 1 on the bottom. So this 0 becomes a 1. This 1 becomes a 2, and this 1 becomes a 0. We're going to slide everything to the right one. So I'm going to show you what happens to your ordered pairs. If I slide every one of these x values 1 unit to the right, the -2 becomes a -1, the -1 becomes a 0, the 0 becomes a 1, the 1 becomes a 2, and the 2 becomes a 3. I basically am going to add 1 to every single one of my x values because that's what this horizontal shift 1 unit to the right does. The next thing that I'm going to look at is what does putting a negative in front of that do? So if I put a negative in front, that's affecting the vertical, and verticals are just your y values. So the first thing, since it was horizontal, it had an impact on your x values. They all got 1 added to them. The next thing that we have is a negative, and that's a vertical. And verticals change only the y's. So now all of these y values, instead of it being a positive 4, it gets reflected to a -4, but it's 1 unit to the right. So all I want to do is I want to take the negative sign and apply it to my y values and multiply every one of those by a negative. So it's going to be -4, -1, 0, -1, -4. And these are the ordered pairs that I should see on my graph. So the -1, -4. Clean that up a little bit. I go -1, -4. Got a color here. I also want the order pair 0, -1. Then I want the order pair 1, 0. Then I want the order pair 2, -1. And I want the order pair 3, -4. So this is the final resting place of this function. Now you can get the same thing by saying I'm going to slide it right to the right one place, and I can reflect it downward. So I'm going to flip it up, down, and that's my final resting place for it as well. This set of ordered pairs might help you in getting more of your locations of your points more accurately described.